It's actually 40 because it's 8 cubes. If I could draw or do this would be 8 cubes. Is when I drew the cube, in real time, I realized if I attach the vertices of the cube, if this was real and not a two-dimensional flat piece of foam, if I were to take a three-dimensional cube and turn it, the vertices of all the corners would stay the same, but then you'd have black in the center. So this side of the cube represents the pigment, and this side represents the light. So light waves would be additive colors. Black represents the pigments. Pigment mixing represents subtractive coloring. So let's go back to light first. I had to draw a mini cheat sheet because I have a hard time remembering these things as well, and I don't want to say it wrong. So if you look at the light waves of yellow, it is green and red, and blue is blue. Together, yellow and blue is RGB, white light. Same thing for this one. Cyan is made of green and blue. Red is made of red. RGB equals white light. This one, green and magenta, is made of red and blue. RGB equals white light. I haven't done this side yet for the pigments, but if you were to mix these colors together, for example, cyan and red, or green and magenta, or blue and yellow, you'd think blue and yellow makes green, right? But what I looked up and research said that the exact pigments down to the nitty-gritty of them don't actually turn it the color you would think. It actually turns it more of a brown or black. So I bought 3 flashlights, and I'm going to put some paper over the front of them, and I'm going to work on showing that these wavelengths together combined makes white, these make white, and these make white, to show the light spectrum and the pigment spectrum all on the same cube. But this little theory of my color cube, I don't know if it exists already or not. And then I created ideas to go with it, because think about it. If you have light waves combining to make white, that is additive coloring. You're adding light waves together to combine and make a color white. But if you're using pigments, then you're actually using subtractive coloring. It's kind of how I use this tool. If you were to mix these together, they would be black. So technically, if you start with that, take colors out, then what are you left with? So in a way, like opposite, in saying, okay, we're feeling really, colorful, really dark color. And then all the colors that are in this cube, not just these 6, all of them. There's so many hues and tints and shades within this idea. They become opportunities to transmute the opposing color through subtractive color, or to add to the color using light. So think about it. Either way, this is my 2D, but actually 3D cube of awareness. And also, it's actually 40 because it's 8 cubes. If I could draw or do this would be 8 cubes. But I can't. We're in kindergarten. And what I mean by 8 cubes is, like, if you can picture this cube moving, now that feels really confusing, right? That's what I kind of tried to show. But really, truly, the simplicity of the cube of awareness is supposed to allow you to pick one thing and have your focus point on that. And so when I talk about the 8 cubes, which you can't see because I'm rotating a 2-dimensional piece of foam, it's actually a 4-dimensional multi-cube that rotates and compacts and rotates into itself. Like, I don't know how to draw that. I don't think I could draw that. But I've seen it. I've seen it in visuals online, and so I know that it's there. And one day I'll figure out how to either learn the online software to represent this idea, or maybe I'll find a friend that knows physics or graphic design, like software kind of stuff. Like, I've tried it, but I can't get the points to stay to the cube. And so when I bevel it, the points disappear. And so that's where I'm at. We're learning all of this together. So here we're at our foam 2-dimensional cube that is visually 3-dimensional. I made a language, a color. Like, how expansive we could go with all of these colors. I'm so excited.